Alright, boys and girls, before we begin, I just want to say you guys have been doing a fantastic job turning these problems in. I see some great work coming out, and I'll be putting up some of those on our future videos. I just want to also thank Miss Wall and Miss Cavill for joining in with us, along with Miss Bonda's class. All of y'all have been doing a fantastic job on these problems of the day. So let's jump into our answer for yesterday's problem of the day. The question was, there were 745 fans at the basketball game. 378 more fans came in to cheer on their team. How many fans were there at the game? So we know that to start, there were 745 fans, and we had 378 more come in. We don't know how many there were at the game altogether. Alright, so let's think about our question. How many fans were there at the game? I'm going to come down to our verify section to do our solution statement. There were unknown fans. And of course you could put at the game or however else you want to complete that sentence. So now let's take a look at our organized section. We have some fans that are there. There were 745 fans that were there. And we know that 378 more came in. What we don't know is how many there are at the game. So we know that if there's more fans, we're probably adding, because we're not multiplying fans or anything like that. There's not fans in different sections. This is a join problem. 745 fans, 378 more came. And how many were there in all? 5 plus 8, 13. 7 plus 4, 11, and one more is 12. 7 plus 3 is 10, and one more at the top is 11. Don't forget to put your comma. There were 1,123 fans at the game. Alright, so now let's take a look at our guiding problem for today. There were 78 kids at the playground. Some kids arrived at the playground an hour later. Now there are 122 kids at the playground. How many kids arrived at the playground? Alright, so we know that to start, there were 78 kids at the playground. We don't know how many kids came an hour later. We know that the total was 122. So let's look at our question. How many kids arrived at the playground? We have unknown kids arrived. And then you can put at the playground or however else you want to complete that sentence again. Okay, so let's think very carefully. We know that there were 78 kids at the playground. We know that some kids came an hour later. And now there are 122 kids total. We could also use a part-part whole, Matt, to think about it, although this is not a part-part whole problem. So we know that there's 122 total. There were 78 kids to start with, and we don't know how many came. Now, when we think about organization and structures, this problem is going to be a join problem. We're joining because we had some amount of kids there, and in the problem, in our story problem, some kids came. So there are more kids coming. So there are kids joining the kids that are already at the playground. Now, when we launch this, though, some people like to think, well, if it's a join problem, then you're adding. No, we have an unknown here for our solution statement. equation, I'm sorry. So when we're going to solve this, when we're going to launch it, we're going to subtract. Yes, it's a join problem, but we're looking for how many kids came in. So we had a total of 122. We're going to subtract the 78 that were already there to find out how many kids came. I'm going to regroup from my tens. Brought in 10 ones, already had 2, so that's 12. 12 minus 8 leaves us with 4. If I only have 1, I can't subtract 7. So I'm going to bring over 10 tens. The one I already had, so that's 11. 11 minus 7 gives us 4. And there's our answer. 44 kids arrived an hour later to make 122. Biggest key here, yes, it's a join problem, but we're subtracting to find that change unknown. We don't know how many kids came. All right, hope this helps you in today's problem. Have a fantastic day, you guys.